Hello guys, welcome back. Now we will see protocol format. Protocol format IPv4 IPv4 protocol format already we have seen. Now we will see IPv6 protocol format. Okay, so let's see. This is base address format. Okay, so this is base address format. Before base address format, we will see one thing. IPv6 datagram. Okay, so like we have IPv6, this is IPv6 datagram format. So we will divide in two parts. First is base header, second is payload. Payload have two parts. In two parts, what is we have in two parts? First is extension header, that is optional, and the second is data packet from upper layer. Okay, this header, this base header is having 40 bytes. Okay, that is fixed. Okay, and this remaining second part having up to 65,535 bytes. Okay, so this is the datagram format of IPv6. Now we will see this base header format. Okay, so this is IPv6 base header format. In IPv6 base header format, we have 8 fields. Okay, the first field is version, the second field is traffic class, the third is flow label, the fourth is payload length, the fifth is next header, the sixth is hop limit, the seventh is source address, and the eighth is destination address. Okay, so one by one we will see what is version, traffic class, and one by one we will see. Okay, so let's start. The first is version. Here VR means version, IP version 6. The value of VR is here 6, and in previous IPv4 the version value is VR value was 4. Okay, the next is traffic class. What is traffic class here? The version is 4-bit field. This is 4-bit field. The traffic class is 8-bit field, is used to distinguish different payload with different delivery requirements. Okay, it replaces the service class field in IPv4. Okay, in IPv4 we have service class, but here we have traffic class. Okay, and that is 8-bit. Now we have flow label. Flow label is 20-bit field. What is flow label is doing? Flow label is actually, we will talk about flow label in detail, exactly what flow label is doing. Okay, so let's talk about first flow label. What is flow label is doing? If we are simplest form, if we are saying flow label, a flow label can be used to speed up to processing of a packet by a router. Okay, when a router receive a packet, instead of consulting the routing table and going through a routing algorithm to define the address of the next hop, it can easily look in flow label table for the next hop. Okay, so what is the meaning? In router we have flow label table. Okay, so what we are saying sometimes we are no need for watching in flow table, just we can proceed. Okay, so that's it about flow label. And if you want, I will explain more about flow label, then I can explain. Okay, flow label. First we will talk about flow label. Okay, flow label. To a router, a flow is a sequence of packets that share the same characteristic. Means here what I'm saying here flow label is, to a router it is a sequence of packets, okay, with same characteristic. Same characteristic means such as like as a traveling the same path, their path is same. They are using same resources, having the same kind of security. Okay, and so on. So this is all about flow label. Okay, and in flow label, a router that supports the handling of flow labels has a flow label table also. The table has an entry for each active flow label. Each active flow label. In this flow label table we have entry of each flow label. Okay, these are flow labels. Each entry defines the service required by the corresponding flow label. When the router receives a packet, it consults its flow label table to find the corresponding entry for the flow label value defined in the packet. Okay, so this is about flow label. Now we will see next. The next is payload length. Okay, payload length. What is payload length? The next is we will talk about payload length. Okay, payload length is here 2 byte long. Okay, length field define the length of the IP datagram excluding the base header. Okay, that is all about payload. And the next is next header. The next header is 8-bit field defining the header that follow the base header in the datagram. Okay, the next header is either one of the optional extension header used by IP or the header of an encapsulated packet such as UDP or TCP. Each extension header also contain fields. Okay, so next is hop limit. Hop limit is 8-bit long. The 8-bit hop limit field serves the same purpose as the TTL field in IPv4 is doing. Okay, so it is same. And the next is source address. The source address field is 16-bit or otherwise 16 byte, otherwise we can say 128-bit internet address that defines the original source of the datagram. The next is destination address. Destination address also 16 byte and 128-bit internet address that usually identify the final destination of the datagram. Okay, final destination of the datagram. So we have seen base address format. Okay, here if you can see, if you are watching this, what is this line is saying? This line is saying that is we can extend this. We can use here extension headers also. We can extend this source address and destination means base address we can extend. Okay, so let's see next. The next is extension header format. In this diagram you can see this next header having some extension header format, like we can extend like this. Okay, so let's talk about extension header format. What is extension header format? The length of the base header is fixed at 40 bytes. Okay, already we know base address is already fixed 40 bytes. However, to give more functionality to the IP datagram, the base header can be followed by up to 6 extension headers. Okay, we have 6 extension headers. We will talk about 6 extension header. These are 6 extension headers. First is hop by hop, the second is destination, the third is source routing, the fourth is fragmentation, and the fifth is authentication, and the last is ESP. Okay, one by one we will talk about hop by hop. What is hop by hop? Okay, the hop by hop option is used when the source need to pass information to all routers. Like we have source and we wanna pass to every router. Okay, that's called hop by hop extension. Okay, now the next is destination. Destination means like our source is want to send only destination. This source don't want to share information with any other intermediate routers. So that's called destination extension header. Okay. The third is source routing. What is source routing? Source routing means the source routing extension header combines the concept of the strict source route and the loose source route option of IPv4. In IPv4 also we have source routing. The source routing header contain a minimum of 7 fields. Okay. So 7 fields. Okay. The first 2 fields, next header and the and header length, are identical to that the by hope extension header. The type field defines loose or strict routing. So that is source routing. And the next is I hope you understand what is source routing. In source routing we have some rules and some rule and regulations, like this is first address, this is second address, this is third address. If you don't understand, 1 minute, give me 1 minute, I will explain. What is source address is saying? Source route is saying, like I decided I am a source. Okay, I am a source and I decided I want to go first. I will go my packet will go to router 1, router 2, router 3, router 4. After that it will reach to destination. Okay, for example, like I wanna go somewhere. I wanna go in other city, and this is my destination city, and I said to that bus conductor or bus driver, I want to pass these cities first. First I want to pass this city, after that I want to pass this city, after that I want to pass this city, after that I want to pass this city, and after that I want to reach here. Okay, so I decided the route of the destination. That's called source routing. Okay, so now we will move on fragmentation. Fragmentation in IPv4, fragmentation is conducting by host and source. Okay, not source, router. That was router, host and router. Okay, but here no need for router. Host can fragment itself. Okay, so that is fragmentation here. Authentication means is here, like we have one packet. Authentication means here we have one packet, and we are just the authentication extension header has a dual purpose. First purpose is it validate the message. This is packet, though it is validate the message sender and ensure the integrity of data. Means this is packet, we are just ensuring, means validating the sender. Okay, this is sender. Validating and integrating means what is the message what is the integrity of the data in the packet. That is authentication. Okay, we are just checking that that sender is authenticate or not. ESP. Then the last is ESP. ESP is encrypted security payload. Okay, is an extension that provides confidentiality and guard against eavesdropping. Okay, the security parameter fields is a 32-bit word that defines the type of encryption and decryption used. Okay, so we got why we are using this encrypted security payload extension header, because we want security. For that reason we are using this. So this is all about IPv6 protocol header format. Okay, thank you.